Okay, we have a problem here where we want to find how many pounds of coffee. We have two kinds of coffee. One costs $2.55 per pound, another costs $4.23 per pound. And you might imagine that maybe the more expensive one's not selling very well, so you decide to mix it in with some of the cheaper one to form a cheaper batch that costs $3.52 per pound. So what we're dealing with here is a situation where we're mixing things. And you really have this same scenario of that we discussed in class, where you have the cost per pound times the number of pounds will actually give you the cost. So you have that relationship, that multiplicative relationship. Multiply one by the constant to get the other. And so when we have that scenario, we can use an approach using a mixture problem. And so the idea in a mixture problem is, again, we start with what we're doing. In this case, we have really two containers that are being put together. Two containers or two buckets, two bowls of coffee to produce a third. And just like we did before, we can label. So here we have coffee costing $2.55 per pound, so I'll label that. Right, that fixed amount there. Same thing, $4.23 per pound. And then the other coffee costs $3.52 per pound. Now we know in the end we need 100 pounds of coffee. What we do not know is how many pounds of the other two. So I might, for example, call this C for the cheaper coffee. And then the question becomes, well, what am I going to let that one be? Remember, in these problems, we're constraining ourselves to only using one variable. So the idea, again, that we used before, still works here. You have $100 pounds of coffee. We know that some of that coffee is taken up by group C. So the question is, what's left? The two together have to total to 100. We have C units of it here, so we must have 100 minus C units for the other coffee. And so the other quantity there, the amount of coffee we have pound-wise, is 100 minus C. And then because of that multiplicative relationship, that relationship that in these problems, that relationship that in this case, the cost is equal to the price times the poundage. Right, because of that multiplicative relationship that we have, we can now just multiply down. Take my cost, or take my number of pounds, C, times my price, $2.55, to get my cost. And likewise, the same thing. $4.23 times 100 minus C equals $3.52 times 100. And that gives us our equation. And again, the fact that we can carry the operations, equality and addition, through, have to do with the fact that this is multiplication. Multiplication will distribute. So now we have our equation, it's just a matter of solving it. So we simplify. And then go through and combine your like terms. So you have a 2.55C minus 4.23C is a negative 1.68C. plus 423 equals 352. So now we want to get C by itself, so we need to subtract 423 from both sides. Doing so will give us a negative 71, and then we divide both sides by negative 1.68, or 1 68 hundredths. So 42.2619, and so on. And let's say here that there's going to be some limit to how exact we can measure this coffee. So we say that we want to round to the nearest tenth. So we would need 43.2 pounds of that type of coffee. Now, in our problem, we wanted to know how many pounds should be mixed with coffee costing $2.55 should be mixed with coffee costing $4.23 per pound to make 100 pounds of coffee costing $3.52. So actually, in this case, we just wanted to know how many pounds of the first kind. We actually didn't even ask about how many pounds of the second kind. So that's actually our answer, 42.3 pounds. Now, if you did want to know how many pounds of the more expensive coffee, even though that wasn't asked in our question, we could go in and realize, well, it's 100 minus C. And so, even though we weren't asked the question, we could still answer that question and find out that there are we would need 57.7 pounds of the more expensive coffee. Okay, well, hopefully that helps you out with mixture problems, gets you a good start. Again, we don't have to actually be mixing things. Anytime you have equations that have that relationship, or a situation where you have that relationship where things are multiplicatively related, and you're taking two groups of things, or maybe even more than two groups of things, and trying to put them together to form one thing, this approach of a mixture problem will help you out.